Okay, yesterday we talked about congruent figures. And what were the things that we discovered about those trucks? To be congruent, have to be the same size, same shape, same pattern even, the design that was on those. So when we are looking at triangles, we don't have a design on the inside of it. So they have to be the same shape, triangle, same size. What's going to determine the size? The angles and the side measurements we have to look at as we compare triangles. Now, what we were looking at yesterday were we had to do all parts. Now, if you looked at all sides and all angles, you realize there would be 6 things you have to look for on the triangles. 3 pairs of sides, 3 pairs of angles. We're going to see if maybe we could do with less. Like, could we do just all the sides? Or could we do just all the angles? So what really would make triangles congruent? So we're going to do a little bit of experimenting and see which ones work. So let's try, and that's what I'm talking about, can we make triangles with less than every 6 parts? Okay, we're going to try and construct a triangle. So you need measuring tools, construction tools, and some paper. Not going to work for you on a marker board or the iPad. All right, we're going to try and construct a triangle out of 3 side lengths. So I want you to start by drawing with your ruler on a sheet of experimenting paper a 4-inch segment. Measure it exactly 4 inches. Got a 4-inch segment? Okay, now it says step 2. From one end point of that segment, construct a 2-inch segment. So I would take my compass and line it up on your ruler so that the point and the pencil are 2 inches apart. That's the part that's kind of a little bit hard to do exactly. And I don't care if you go from the left end or the right end. Once you have it set at your 2 inches. Go from one of the ends and make an arc. We did a construction kind of like this to make triangles earlier. So somewhere on that arc, it would finish the triangle and that segment's going to be 2 inches long. From the other end, I want you to construct a 3-inch segment. 3 inches. From the other end point. Your 2 arcs should cross because 2 plus 3 is bigger than 4. So it's going to make a triangle. Okay, so where those 2 cross, that's going to be the last corner for your triangle. So it's not exactly making an isosceles triangle because those lengths are different, but it's kind of like that construction. So finish your triangle now. Connect that point to the ends of the segment you started measuring. Now, do you think that the triangle you made is going to be identical to a neighbor's triangle? I think they will be. Make it the same way. Okay, so take your paper and you might have to tear out the paper to put it on top of another one. If you hold it up to the light, you can probably see through. Let's see. Okay, I need you to do some comparing. Compare your triangle to a neighbor. from that point. Okay, how's it comparing? Match it up? Yeah. This person, this R. Yeah. Nine? And the two endpoints. That one that's kind of scribbly, that arc doesn't come from the one at the ends of the segment. The point that compass there. I have to position it back if you want that.
Sure.
The two triangles the same? You compared that way, and how about compare with Andrew also? All right, as I'm walking around and looking, these do look pretty much the same. All right, so what did we use? Let's call it. Is this 2 inches? Is this 3 inches? Okay, so that should have made 2 triangles. Are they identical there? Okay, were any of the triangles flipped over? Like they put the short one on the left instead on the right? No, everybody did the very same? Okay, there's a little yes back there. So you could have the triangle flipped over, but that is still the same triangle. Remember your trunks, we could flip it over and it's still matched. So what we did right there was, out of all 3 side lengths, we created triangles that were identical. Let's try it with angle measures. Instead of side lengths, got a protractor in your packet? Everybody got one? All right, let's have you make a triangle that has a 40-degree angle, a 60-degree angle, and an 80-degree angle. Okay, well, how would you do that? Let's have you start drawing. And make a 40-degree angle. You'll need your protractor. That one didn't have a protractor. So from one end of the segment I drew, I'm going to line up my protractor and measure 40 degrees. There's a 40-degree angle.
How long is it, that line?
Doesn't matter. If you choose your length, will you end up with a triangle that's the same size as yours?
Yeah, they're all the same.
So if she measured out, 4 inches and then made her 60-degree angle, and if Ben measured out only 3 inches and did his 60-degree angle, notice how those would be different triangles? Okay, so in order for us to get the same triangle, I have to give you another measurement. I have to give you a side length, don't I? Okay, so what you told me is just all angles isn't enough. I need to give you a side length. So what's a good side length there? 3 inches? Okay, so let's make that side 3 inches. And then let's have everybody do the 60-degree angle on this end of your 3 inches. So measure 3 inches, put a dot there. So you've got this angle, you've got this side. I'm going to have you measure, not on the outside, but on the inside, coming around here. 60 degrees. what I'm doing? Got your 40-degree angle then? No? You know how to use your protractor? You got a segment drawn there? Okay. Okay, so if we got it on the lip. Okay. Alright, so then on this end. So on this end, like that, that's gonna be the corner angle. And I'm making 0, going up to like 40 to the mark. And connect now. This is going to that. That makes it 40 degrees. You have to draw the sides of the angle out far enough that they cross to finish your triangle. Now from that, we're going to 60. Okay, how many degrees is the last angle in your triangle? 80? Look at your neighbors. Do you have similar triangles? Excuse me? 76? You might go back and measure. Is this really 40 and that's really 60? So it should have been 80 degrees for that last angle. Because the three angles have to add up to 180. Okay, so compare your triangle to a neighbor's. Do they match up the same? These don't look quite the same. These are different. That angle's 40 on both of yours. I don't know if you did. Is this angle 60? That one's right. So we get 60 degrees over here. That's only 40.
Oh, and then,
And did you measure this 3 inches? I don't think it really is, no, so it's smaller.
yeah,
Okay, is that one working? Okay, so let's, I'm gonna make some notes on the board here, so that when we get to our actual theorems, we know what's going on. Okay, on this one, we did all 3 sides. On this one, we ended up doing a side, but then we put an angle on each end of it. All right, we're gonna try one more. I'm gonna give you an angle and then 2 side lengths. So we didn't even need this 80 to make it. Okay, let's do a triangle that has a 50-degree angle. And one side of it is gonna be 2 inches, the other is gonna be 3 inches. When you get that much drawn, then finish connecting to make a triangle. So you might start by creating your 50-degree angle. Make your angle 50 degrees. Now that 50-degree angle is supposed to be like in the middle of a 2-inch and a 3-inch segment. So measure one of those sides, make it 2 inches. Get rid of the rest of that. And measure the other side, make it 3 inches. If your 2 and 3 inch are flipped from mine, that's fine. Mark which is the 2, which is the 3. Then the end of the 2 inch and the end of the 3 inch, just connect those and you'll finish making a triangle. Got it figured out? Okay, let's compare the last things and see if our triangles are the same. So that's what we made it out of. We made it out of an angle, and then we put a side length on that end and a side length on this end. That's what we used to make it. Now let's see if those are the same. What's your third side length? How long's that last side? Okay. Measure that last side. 2 and what? It's about 2.5?
It's about 60 millimeters.
She's going in.
It is 60 millimeters.
Alright, I'm
There
going
we
in
go.
inches.
I like millimeters.
Kinda hard to tell there, huh? 2 and 2/16? What was yours? 2 and 5/16? 2 and 3/16 she's got. We're not completely perfect, are we?
I got like 2 and 4/16. I got
No, that's hard for me to compare to the rest of these. Okay, let's measure the other angles. What are the other 2 angles? See if that gets us closer.
45 and 85.
45 and 85?
I got a 90. I got 94 with a side of 3 inches or 2 inches. I got a 93.
Alright, this one's not working as good for us. This is supposed to make 2 triangles that are congruent. Everybody should have the same triangle. So we must not be measuring real accurately.
I got 40, 50, and 90.
40, a 50, and a 90?
Not a 90. I got 90. It was 90.
Alright. Alright, so rather than debate about it, I'll let you know that that was supposed to make 2 triangles, or triangles that were all congruent. So we must not be measuring our 50-degree or 2-inch and 3-inch exactly right, because we've got a little bit of variation. Alright, those were supposed to work. So let's catch up with some note taking. The first one that we did is a postulate. It's called side, side, side congruence postulate. Side, 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 that's the first one that we did here. Side, side, side congruence postulate says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. That was our first construction drawing that we did. We used all 3 side lengths. That one seemed to work pretty well for us. What we're going to be looking at today is, we're going to be answering the question, are the triangles in the diagram congruent? Are they identical, same size, same shape, same lengths, same angles? And instead of having to look at 6 things like we did yesterday, this postulate says you don't even have to worry about the angles. If all the side lengths from one triangle to the other match up, triangles are going to be congruent. So that saves us half the work from yesterday. So what would it look like if I put markings? Let's say this side's congruent to this one. There's 1 pair of sides congruent. A second pair of sides congruent. And a third pair of sides congruent. So if all 3 sides of one triangle are congruent to the corresponding 3 sides of the other triangle, then the triangles are congruent, identical, same size, same shape. They could be flipped over. They don't have to be sitting the same direction. Question on that one? Let's see, I don't want to go completely out of order from my presentation, so let's see what I had on my next screen. Right? Can I go on? All right. So you'll have questions like this. Are the triangles congruent? All three sides in one triangle are marked the very same as three sides in the other? Okay, so yes, they are. Now, normally the directions then will say, write a congruence statement. So triangle ABC is congruent to triangle RTS. It's a little bit harder to match them up because you really don't have the angles, you have the sides to look at. Okay? All right, and what's our reason that they're congruent? It's by the side congruence postulate. Okay, let's try this one. Are the triangles here congruent?
Yes.
Sure. All three side pairs?
Yeah, and AC and BD are parallel.
Oh, you're seeing some things that I'm not seeing. A, B, C, C, D, B. Okay, what things are you seeing congruent? Segment AC is congruent to segment BD. Segment AB is congruent to segment
CD.
CD.
CB is congruent to CB.
Give support.
They're the same line.
Same line. Segment CB is congruent to segment CB. What property does that sound like? Reflexive property. Yes, they're the same segment. Reflexive property supports that. So yes, I haven't marked it, but now I will because I agree with you. Reflexive property can tell me that segment CB is congruent to that segment CB. So you were right saying yes, but I didn't know if you really thought about that other side pair. So triangle ABC is congruent to triangle, I think that's right, DCB. What's our reason? We did use reflexive property, and then in the end, it's side congruence. So we used reflexive property and side. Are the triangles here congruent? Now before you say yes or no, you got to do some more thinking. Okay, tell me some things. Okay, Tom,
That means the midpoint of RG.
Yep, it's
That
given.
means those two sides are congruent.
Okay, so midpoint means that this would make segment MR the same length as segment MT. MR, MT. Ben, I know, that's all right. It got you up here. So what's something else that we know congruent?
As is congruent to
Reason?
reflexive property.
Okay. You'll never stretch again. Okay, another thing, the obvious one. Our S was congruent to ST because it was given with the tick marks. Are these two triangles congruent? Yes, by side congruence postulate. Okay? And I think you're getting the idea of matching up the triangles, so I'll skip that part. Okay, we did a lot of these investigations to start with, so instead of doing them separately. The second one that we did, no, the third one that we did, the one that didn't work so well for us, that was called side angle side is what I meant. Side angle side congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. But we need to talk about what included angle means. Included angle. The included angle is the angle where the two sides come together. The two sides come together. That angle is the angle that is included. So I'm going to mark just two sides congruent. Let's go, this side is congruent to this one. And then this side's congruent to this one. So there's my two sides. Now the angle has to be included between them. The angle has to be where those two sides come together. So as long as this angle is congruent to this one, that's a picture of side angle side congruence. That will always make the same triangle. Two sides on the board, which is the included angle. Top, left, or right?
Right.
With him on that? It's where those two segments come together at this point. So this is the included angle in that triangle. This is the included angle in the other triangle. As long as it's between those two, that's going to be side angle side. Done with the notes? Okay, so are these triangles congruent? That's exactly what I've got on the board, isn't it? All right, so yes, they are, and again, we could match them up. But now it's not side, 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 it's side angle side congruence instead. How about this one? Draw the triangles separate. You're going to have to do this separate drawing on your problems on homework if they're hooked together. You're going to have to separate them. You've got this segment congruent to this one. This angle is congruent to this one. What else? Jamie. Lizzie, I'm sorry. Sister. Okay, the reflexive, are you saying the segment, or did you say, yeah? Okay, the segment. Okay, so Lizzie's got the segment HF congruent to the segment HF, again, that reflexive property. So now that we've pulled it apart, see the two sides and the angle between. So that was another yes by side, angle, side. And how about these triangles? Information that's there. AB is congruent to BC, right angle. This would be a right angle also. And that BD, reflexive segment. See how we're using the reflexive property a lot? Don't know that. I don't think that there's a reason for that. So here we've got two sides and the angle that hooks them together is congruent. So this is a yes. We've already got side angle side congruence. All right, thumbs up or down. Do you understand side angle side? Yeah? Okay, then the second one that we experimented with was angle side angle. Oh, looks like I had one more example. What can you come up with? There's no reflexive in this one. Well, they are kind of flipped over. We've got sides. Is there an angle that's congruent?
Vertical angle.
There we go. Vertical angles are congruent. So that can be in there.
Those two are the same line.
I can't hear what you're saying.
Since it's a vertical angle, they can go up and
Yes, we had a theorem that said vertical angles are congruent. Okay. Looks like I had more examples than I thought. Are these triangles congruent? Well, we've got the reflexive. We've got this segment congruent to this one and parallel. What can we get from parallel lines? Remember things like alternate interior angles? So this angle formed from the parallel is congruent to this one that's formed from the parallel. So there is side angle, side, each triangle has two sides, and the angle that's between them. Two sides, and the angle that's included between them. All right, finally, and we did the experiment already. So angle, side angle, that's the second one that I had you do. You told me when I gave you just angles, you needed a side length, so I gave you one to put between two of the angles. So the idea of the angle, this time the angles are the ends of the side. The side is included between the angles. So this one's angle, side, angle. Got one side and two angles. The two angles have to be on the ends of the side. So something like that picture. Side is the same. The angles on the ends of it in both triangles. That's an angle, side angle. Understand how the picture goes? Got a side, angles on the ends of it. Because there's one more that has two angles in one side, but the side doesn't hook the two angles together. It's arranged a little bit differently. Still need the screen. How much is it supposed to snow tomorrow? I was thinking I saw 2 to 3.
Look, it's 60 degrees tomorrow, so everybody's like,
Yeah, and then it would rain instead of snow.
I would prefer.
All right, anyone still need it? I have to teach Tiara's shorthand. Speed writing. We're almost to March.
Oh, I get it. Yeah.
Okay, so are these two triangles congruent?
Yes.
So which one is it?
Angle, side angle.
This is the angle, side angle. There's two angles and the side that's between them. So yes.
Yes. Yes.
There's no angles or sides marked.
Well, you got
What do those
parallel.
arrows mean?
Parallel.
Parallel,
Those
so
would be the same thing.
well, what can we get from parallel?
But they're the same thing.
What do you mean they're the same thing?
They're the same.
Yeah, does parallel mean they're the same length?
No.
No.
They're going forever, but they're the same, like.
Okay, they don't touch each other. So we could do something with angles, like alternating tier angles idea. So let's see.
And then the arc.
Parallel, hang on. Parallel line, transversal, parallel line. So we can get this angle congruent to that one.
And then we can get
And then, just a second. Okay, parallel line, transversal, parallel line. In blue, this angle is congruent to this one.
and then RT would be the same thing. Because they're reflecting.
Correct. So if I pull the triangles apart, one triangle's that way, one triangle is this way. Notice they are congruent by angle, side angle. So some of our problems we have to think a little bit harder about. What's it mean if segment DB bisects angle ADC? Okay, so this segment cuts angle ADC in half, meaning those two are the same. It also says it cuts angle ABC in half. So these two are the same.
And you know, since the reflexive property, AB is.
Allie's getting very good at reflexive property. Are the rest of you doing that? Okay, so you can connect those together. So this side, the angles on the ends in that triangle, and in this triangle, there's another example of angle side angle. All right, we've got one more theorem. This one is the one we did not try, because it's kind of hard to try. But it's angle, side. The only difference between the last one, angle, side, angle, and this one, angle, side, is where the side is related to the angles. This one, the side does not hook the two angles together. It's not between them. So angle, side. Would be two angles again. But now notice what you're writing down says a non-included side of one triangle, congruent to two angles and the corresponding non-included side of the second triangle. So the sides have to be related in the same place in the triangles, but not hooking the two angles together. So two angles and the non-included side. Non-included side, not the one that hooks those two angles together, but it needs to be in the same place in both. So if I put angle, and then mark the side over here off of the double angle, it has to be off of the double angle on that one also. On the front board, maybe I'll mark the first side. That's still, maybe you'd say it's side, angle, but if I reverse it, angle, side. So you could say this as side, angle, but I'll tell you, I'm used to saying angle, side, so that's the way I'm going to say it a lot. So it's, the side is not included between. Now there are some of the beginning problems on your homework, they're just going to ask, what's the included angle, what's the included side? So hook together is the idea. I think we need to do some examples before we close up shop. Can't just give you that. How about if I come back to this screen for those note takers to finish up? I want to do a couple examples and then I'll come back to this screen. So are these triangles congruent?
Yes.
Which one is it? I think it is angle, side because we've got two angles, but the side's not between them. Okay. How about this one? Okay, vertical angles could be used again. And notice in the triangles, you've got two angles, and the side is not hooking them together, so that is angle, side in both triangles. I should stick a no in here sometime. Are these triangles congruent? What do we need to come up with though? I think you've done that. What are some other things? Okay, reflexive property, yes. What else? What can we get from parallel lines? Okay, we can do something like alternate interior angles that are congruent. And so we've got two angles and then the side. Two angles and then the side. So that one's another angle, side. All right, so let's get to some problems. No, that was just what we were gonna do for some more practice problems. Let's get to the actual homework problems. They actually started where those left off. So we're gonna do page 245, starting with 9. And on 254, we're starting with 10. Plus the odds. We're gonna use these again on Monday and add one more to it.
That sounds delightful.
And then do some proof type things.
That doesn't
Do we
sound
need these?
delightful.
Do we need these?